Hello everyone, welcome back to my YouTube channel. My name is Lav Kumar HN, Department of IAC, Shri Venkateshwara College of Engineering, Bengaluru. Today I'm going to explain you about local replication systems. It's under subject called Storage Area Networks and subject code is 18CS822. Now, what is data replication? Data replication is the process of creating, maintaining copies of data to ensure its availability, accessibility, and resilience against failures. Why we need data replication? For data availability and resilience. Data replication is crucial for ensuring high availability, disaster recovery, and business continuity in IT environments. Overview of local replication technologies. Local replication technologies enables creation of data copies within the same location, providing redundancy and fault tolerance. So, in simple words, if I want to tell you, means imagine you have a favorite recipe book. You want to make sure you always have a backup in case the original gets lost or damaged. So it's like in making photocopies of that recipe book. You create identical copies and keep them in different places. Why so? So that even if one copy is lost, you still have others to cook from that recipe book. So in simple words, this is what data replication. Now in this data replication, we have different types, that is mirroring, snapshotting, replication, clustering, and RAID, redundant array of independent disks. Mirroring. So mirroring involves creating an exact replica of data on another storage devices. This can be done at the block level or file level. When data is written to the primary storage, it is simultaneously written to the mirrored storage, ensuring redundancy and fault tolerance. Mirroring is often used for critical data that requires real-time replication and high availability. An example of mirroring is a RAID 1 setup where data written to one disk is simultaneously copied to another disk, creating an exact replica or mirror of the original data. If one disk fails, the system can continue operating seamlessly using the mirrored copy until the failed disk is replaced. So, for example, picture two identical magic mirrors, one in your room and one in your friend's room. Whenever you write something on your mirror, like it's a note or some drawings, it instantly appears on your friend's mirror too. So that's mirroring. So it will ensure that both mirrors have the same content. So I hope you understand the concept of mirroring. Now let's see snapshotting. Snapshotting creates point in time copies of data at a specific moment. These copies are often used for backup, testing, or data recovery purposes. Snapshots are typically taken incrementally, capturing only the changes since the last snapshot, which helps to minimize storage overhead. Taking a snapshot of a virtual machine in a cloud environment before performing system updates or software installations, allowing for quick restoration to a previous state if needed. So, for example, you imagine a photo of your Lego castle at a specific moment. You can always go back to that exact castle design. So it's like taking a photo of your data. It captures how things looks at the particular time, and after later that, if something goes wrong, then it's like a software update causing issues. You can restore your data to that snapshot. So, and in softwares also, when you get some new updates, then you may face some issues or you may face some lag in the experience of your mobile usage. So like that, this snapshotting will ensure the previous experience in failure cases. So I hope you understand this snapshotting concept also. Now let's see replication. So replication involves copying data from one location to another in near real time. There are different types of replication, including synchronous and asynchronous replication. Synchronous replication ensures that data is replicated immediately to a secondary location before a write operation is acknowledged as complete, providing strict consistency but potentially impacting performance. Asynchronous replication allows some delay between the write operation and replication, offering better performance at the cost of potential data loss in case of a failure. So, what is this replication? So, it's a replication. It's similar to data replication. If I want to explain you with an example, means you have a favorite book. You want to make sure you always have a backup copy in case something happens to the original. So, for example, I have a book called for example, how to become rich in 30 days. So, if I want the backup copy, if something happens to the copy what I have, then it's this replication is like making photocopies of that book. We can create the identical copies and keep them in different places. So here already I told there are two types, that is synchronous replication and asynchronous replication. Synchronous is like having a photocopier right next to the book. Whenever you write something in the book, the photocopier instantly makes a copy. It's super accurate but can slow things down. It's like simultaneously the things will copy. When it comes to asynchronous, we write in the book first and then someone comes later to make a copy. It's faster but might miss a few updates if something happens before the copy is made. So the difference here is synchronous takes some time and asynchronous may not take time, but here in asynchronous replication we may have the possibility of missing some information or data. So this is what difference between the synchronous replication and asynchronous replication, and it is all about replication. Now clustering. So clustering means it involves grouping multiple servers or nodes together to work as a single system, providing redundancy and fault tolerance. In case of a failure of one node, the workload can be seamlessly transferred to another node within the cluster. Clustering can be used for both high availability and load balancing purposes. So implementing a web browser cluster where multiple servers are grouped together to handle incoming requests, providing fault tolerance and scalability. If one server fails, another server in the cluster can seamlessly take over. Like for in real time, like if you are anyone organizing a big party, we want to make sure it runs smoothly even if one person suddenly can't make it. I mean, I have organized a party in that dinner, DJ, and different things will be arranged. If something like if DJ is missed, then the party should successfully complete. So if something missed also, it should not have disturbances. So this is what clustering means. So how it works means it's like having multiple, I have told you in that party, DJs, if organizing, we should have contact with the different DJs. If one, the person who we have contacted as first DJ guy, if he misses that party, then we can communicate with another guy and we can make sure that party will complete successfully. So this is how the clustering will work in this data replication. And also it handle more more servers and more events like that. This clustering will helpful. And last, that is RAID. A RAID full form is redundant array of independent disks. RAID configurations combine multiple physical disks into a single logical unit to improve performance, redundancy, or both. Different RAID levels offer various trade-offs between performance, capacity, and redundancy. RAID 1, for example, mirrors data across multiple disks for redundancy, while RAID 5 and RAID 6 use parity information for redundancy and can tolerate the failures of one or more disks. Configuring a RAID 5 array with multiple R drives when where data is distributed across the disks along with parity information, allowing for continuing operation even if one disk fails. In simple words, if you are building a Lego castle where I want it to be strong and safe, even if some Lego pieces break. So this is the condition and how this RAID will help me in these conditions. For example, so it combines several Lego pieces into one castle and that different RAID levels offer different features. For example, we build two identical Lego castles side by side. If one breaks, you still have the other. And in how is this RAID 5 and RAID 6 works means we use a special Lego pieces, like it's a parity information to fix broken parts even if a few pieces break and castle stands strong. So this is what about RAID. So and remember that the concepts what I have discussed till now, that is mirroring, snapshotting, and replication, RAID, and clustering. These ensures the data is safe and smooth operations uh, can be conducted, and also we can prevent the disasters, and we can reduce the fault. We can reduce the failures, and also we will be having some backups. This is all related to the having some backup for the data to make sure we will get the data if something happens to the uh, real data. uh, this is the concept of data replication, and in conclusion, local replication systems are vital components of data management strategies, providing redundancy, fault tolerance, and high availability. So this mirroring, snapshotting, replication, clustering, and RAID are like key techniques used to duplicate and maintain copies of data within a specific environment. These systems ensure data integrity, availability, and disaster recovery, minimizing the risk of data loss and downtime. Organizations leverage these replication systems to safeguard critical data, support business continuity, and maintain seamless operations even in the face of hardware failures, human errors, or natural disasters. So this is the conclusion for this data replication or replication local replication systems. So here we discussed about five types, that is mirroring, snapshotting, replication, clustering, and RAID, and the advantages, disadvantages, and why we need this data replication. All we have discussed in this video. If you want more content like this, please do subscribe to my channel and like this video, share with your friends. Thank you.